All right. There he is. One of my heroes, the amazing, the one, the only, the inimitable, my friend Patrick Curran. Oh, I think he's leaving now. I scared him. Don't leave. It's okay. Yeah. Oh. Wow. All right. Let's see. Can you all see that screen? If you can't, you should come closer. We're going to go through a lot of code, and I want you to be able to see that. Let me see. Wow, that is really, is there a way to turn off the lights or something? That is a diluted screen. Guess not. Okay. Sorry about that. We're starting a little late because we had to set up, and the last talk ran a little long, which is fine. We're a little off schedule today. So, all right, everybody. Thank you very much for coming. I appreciate you coming here and being here. I know that you have a lot of places you could be. Right now, there are some amazing talks by some much better presenters, so I'm grateful for any audience I can get. We're going to go through a lot of code today. I love code. I believe that if we're going to talk about code, we might as well show code instead of slides about code. So as a result, I tend to do, code. So I encourage you, for your own edification, for your own reference, to note that GitHub repository there, github.com, Josh Long, Cloud Native Workshop, where you'll find a 3-day workshop with exercises. Oh, my God. With exercises that you can follow along at your own pace later on. If you have questions, comments, feedback, whatever, I'm happy to hear from you. I want to help, right? So what about Twitter? How many of you are on Twitter? Twitter, it's 2017. Twitter. Anybody? Okay, well, find me there. I'm happy to talk. I'm happy to answer questions, happy to engage. What about email? Email. Anybody? Okay, well, if you're there, don't hesitate to find me there as well. That's distinctly less valuable for the audience, or it's just you and me, so nobody else gets to benefit from that particular thread, but I'm happy to talk there as well. Anything I can do to help. So there's that. A little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm a open source engineer and contributor. I work on a lot of different open source projects, not the least of which are Spring Boot and Spring Cloud and Spring Integration and Spring Batch and Vaadin and Timeleaf and Activity and so on. I am, for those different projects, for the time that I've been committing, in the period in which I've been committing, I have held the dubious distinction of being the #1, top-ranked, most widely recognized contributor of bugs, but still number one contributor of bugs to those projects listed there, right? More bugs per commit than any other developer on those teams. That's all I got, really. So there's that. I'm also a book author. I've been working on books and training videos. I do whatever I can to help spread the word. So, for example, I've just wrapped up the 2nd edition with my friend Phil Webb, the amazing, the inimitable, the co-founder of Spring Boot, Phil Webb. The 2nd edition of our Building Microservices with Spring Boot Live Lessons training video. And right now I'm wrapping up, literally as we speak. I mean, the thing that was on my screen before I sat down here was the final pages, final chapters of Cloud Native Java, a book about how to build applications that survive and thrive in the cloud at scale in terms of Spring Boot, Spring Cloud, and Cloud Foundry. Now, that bird, and I can see it in your eyes, I can see the curiosity welling up. That bird, for those of you who are wondering, is a blue-eared kingfisher. It's a bird that is indigenous to the Indonesian Java Islands. It's, as we'd say in English, native to the Java Islands. Now, birds, you see, birds fly, often through the clouds. So it's a cloud-native Java bird. It's a bird that's native to Java that flies in the clouds. It's cloud-native Java. Never mind. It's fine. It'll come. Give it time. Give it time. So there's that. And I work at Pivotal. How many of you know Pivotal? We're a small company with big dreams and a whole lot of heart. What we're trying to do is to help people build applications and move them quickly and safely from concept all the way through to production, right? Through the workflow, from product management, through user experience, to developers, to testers, to administrators, and then off into production. We have a lot of great open source software at Pivotal, but make no mistake, that is not the reason that we're here. It's not the raison d'etre, right? What we care about is helping people move quickly and safely to production. We see that a lot of organizations struggle with this. They understand that they need to be able to go faster. They understand that they have to capture that agility, but they don't know how. All right. No problem. They understand that they need to go faster, but they don't know how. They look around and they see in the ecosystem a lot of different very successful companies, right? We don't need to look too far for supporting evidence of this. What is right now the largest taxi company in the world today? Uber. What is the largest video rental services company in the world today? What is today the largest hotel brand in the world? Airbnb, right? These organizations and many others besides are not actually taxi companies or video rental service companies or hotel brands. They are software companies. They deliver, release, iterate, and evolve in terms of software timelines, like software companies. When they need to change, they change the software. This helps them go faster. It helps them deliver value to the customer faster. They are able to do so at a much faster pace than their competition. There's other things involved, but by and large, the accelerant here is the addition of software. This is not a new idea either. How many of you have ever read the amazing book, The Inmates Are Running the Insane Asylum? The Inmates Are Running the Insane Asylum. It's a book that has many great takeaways, not the least of which is that if you add software to any existing business, any business at all, you end up with a software company. You take taxis plus software, you get a software company. You take hotels plus software, you get a software company, right? Software and delivery of software is how you add value to modern businesses. So the question is, how do we take existing organizations that have existing applications that were written by a lot of people in a different era, 10 years ago, 20 years ago, software that predates the era of cloud computing and the economics of cloud computing? How do we take that software and move it in these more accelerated, faster timelines? People struggle with this because having existing software is not necessarily a bad thing. It just means that you've been lucky enough to survive, to thrive, perhaps. Taking an existing application and reworking it to be a better participant in this new era, in this new architecture, isn't a bad problem, but it's a problem, right? You do have to get over that obstacle. So a lot of organizations look for ways to take their large, existing, unbroken applications that are monolithic applications and to decompose them into smaller pieces. They turn to, for example, Dr. Eric Evans, who in his great tome, Domain-Driven Design, talks about the idea of a bounded context. A bounded context is a part of the domain model that stands unto itself, internally consistent and reusable. It's something that can be extracted from the larger whole in a way that doesn't depend on any of the other part of the system. A bounded context, if you can identify them, is a natural boundary for what we're trying to do. We're trying to take these large applications and break them apart into smaller pieces. If we can find these bounded contexts, parts of the domain that are reusable and independent, then that's a nice place to make the cut. The benefit of doing this is that if we have a smaller batch of work that we have to move through the workflow from product management to user experience to developers to testers to administrators, if we have a smaller batch of work, then we have less things to think about when we're writing code. The surface area of the code is smaller. We have less to worry about when we do tests because there's not nearly so many repercussions. If you make a change here, it doesn't necessarily invalidate testing results over there. It's easier to reason about from a product management feature. We know exactly what that'll change and how it'll affect people that are consuming it. It's easier to operationalize. If you want to scale it out, you just have to scale that one piece, not the whole application. This gives you the ability to optimize the whole production pipeline, all the way to production. But the question is, what will I face if I attempt this architecture, if I attempt this approach? You're going to run headlong into a few problems when you move this way. The first big problem is how quickly can you, as an organization, stand up a new production-worthy service from soup to nuts, 0 to 60, right? Including handling things like load balancing, DNS, heartbeat detection, failover, security in the application itself, observability and monitoring. How quickly can you do all that? The second requirement that you're going to run headlong into is once I've optimized that, once I've found a way to stand up new applications that are production-worthy, and I've addressed all the non-functional requirements in that, now that I've done that, I've got lots of small services deployed on the network, deployed across the cluster, communicating with each other over network partitions. Once I've done that, now I've invited the complexity of building a distributed system into my life. And if there's anything, indeed one thing upon which I'm sure we can all agree, my friends, it's that building a distributed system is hard. So you need to be able to address that complexity. For that first pain, for that first requirement, the requirement that you be able to build production-worthy services, I wholeheartedly and full-throatedly recommend both Spring Boot as a way of building production-grade applications and services, and Cloud Foundry as a way of operationalizing them. But for the second requirement, you can't just, it's not just business as usual. It's not just about automating and optimizing what we already did. You have to rethink your approach to building services, because these things are not going to talk to each other in a way that didn't necessarily have as many failure modes as they did before. So for that, we're going to look at Spring Cloud today. So a quick show of hands, how many of you have ever seen Spring Boot? Okay, so I won't spend too long on Spring Boot, but I do want to make sure we're on the same page. So I'm going to build a new application because I need to. Okay. So we're going to build a new application here at start.spring.io, which is not found. That's awkward. They're redeploying it right when I'm giving my talk. Well, literally, we'll just sit here. Pardon me. Talk amongst yourselves. I'll give you a topic. Rhode Island is neither a road nor an island. There we go. So we're going to build a new application here at start.spring.io. This is my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go to production as early and often as you can. Bring the kids. Bring the family. It's the happiest place on earth. It's better than Disneyland. Production is great, and if you're not already there, you should be there. But if you aren't already there, you can begin your journey here at start.spring.io. If you want for inspiration in the early morning before a cup of tea or coffee, start.spring.io. If you suffer from indigestion after a long night of alcohol abuse in PHP, start.spring.io. And if your children are restless and can't sleep, start.spring.io. What we're going to do is we're going to build a new application. I don't want to spend too long on the domain of the application itself, so I'll build something called the Reservation Service, which is going to manage entities of type reservation. In order to do that, I'm going to use Spring support for building web applications. I'll use H2, which is an in-memory embedded SQL database. Because it's in memory and embedded, it's going to lose all of its state after every single restart. Very similar in this regard, I think, to MongoDB. It just loses the data all the time for no reason at all, right? Just randomly loses data. So very similar. We're going to use JPA, the Java Persistence API. I'll use the config client for centralized configuration. We'll use Eureka for service registration and discovery. We're going to use Zipkin for distributed tracing. We're going to use Actuator for operational concerns. And I think that'll do. Now, I also want Lombok, the Java compiler annotation processor, right? Now, if I wanted to, I could switch to the full version, whereupon I'll find a veritable ocean of checkboxes, things that I could elect to add to my application, but for my purposes, it suffices to leave things as they are. I encourage you, however, to pursue this list at your own leisure later on. Also, I think I would do well to add dev tools, which allows me to restart the application live without having to recompile and all that stuff, right? So there's that. Now, I want to just take a brief moment to talk about this. These are the three drop-downs at the bottom of the page here. And the drop-downs typically imply choice. And yes, here you have a choice. You have a choice at your discretion of the language that you want to use on the JVM. What language would you like to use? Any language on the JVM that supports annotations and objects will work just fine. So Scala, Ceylon, Java, Groovy, Kotlin, they're all fine candidates, right? Use them as you will. But here, my friends, here we have the appearance of choice where really there is no choice. The first question is, what version of the JVM would you like to use in 2017? As both 1.6 and 1.7 are end-of-life, not supported, no longer generally available except for security updates, and even then, only at the mercy of those select few that care. This is the only real choice. The other question we have is the choice of packaging, and a lot of people get confused about this. They don't know when and where to choose which, so I'll do my level-headed best to explain here and now. If, by some crazy, terrifying accident of physics, some freak fluke of physics, you find yourself stuck in the distant past, far, far, far beyond modern help, then choose .war. But if you're here with me in 2017, then choose .jar. This is a big part of my overarching, guiding, personal philosophy of make jar, not war. And again, you have choices, you have options. You should do what works for you. All right. So anyway, I'm going to leave that as is. I've got a new project. I'm going to hit generate and open this up in my IDE. Oops. Try that again. Open this up in my IDE while taking a sip of water. Now, I'm not going to spend too long on the application itself. Suffice it to say, it's going to be a JPA-based application that persists an entity into a database. So let's see here. We have a reservation service. Okay. And I'm going to create an entity, class reservation. Okay, at entity, private long ID, at ID at generated value. Okay, private string reservation name. Good. Now I need a constructor here, just for that one field. Otherwise, I'm going to let Lombok do all the heavy lifting. I'll make it a data class. I'll give it a toString method here. I'll give it a all args constructor and a no args constructor, entirely for JPA, right? There's that. Actually, I don't even need that. There we go. So that's fine. So I've got that. I want to be able to manipulate instances of this entity. So I'll create a repository, a Spring Data repository. I'll say that this is a repository that extends JPA repository, and I'll manipulate instances of type reservation whose primary key is of type long. And I want to save instances of this data into the database. So I'm going to make my bean implement command line runner. And the command line runner is a callback interface that Spring will call when the application starts up. And it gives me a nice opportunity to do some setup, anything that has to happen in the beginning of the application before work has begun. So I'm going to write some of the names to the database. My name is Josh. Very nice to meet you all very much. Thanks very much for coming. I'm joined, of course, by my buddy Christian and Patrick and James. And who else do I recognize out there? Oh, Martin, of course. There we go. So that's 1, 2, 3, that's 5. I need another name. Miss, what's your name? How do you spell it? Like this? Very good, thank you. That's 6. That's a nice round symmetrical number. And so for each name, let's write a record into the database here, and then confirm that everything is as it should be by logging out the results. Okay. Now there we go. There's my application. I want to have a REST API, so I'm going to use Spring Data REST as well. I'm going to use Spring Data REST, which I don't think I have on the class path here. So let's go ahead and add that. And Spring Data REST will make it easy for me to export my repository as a REST endpoint, a Hypermedia REST endpoint. So repository, REST, resource, thank you. I want to create a custom finder method perhaps, right? So reservation find by reservation name, string rn. And I want to export this as an endpoint as well. So I'll say path by name at param rn. Very good. And with that, we can now run the application. And we should be able to see that everything is working as expected. Hopefully with enough time to spare. There we are. Look at that. We happy 6, all on the console. It worked. Of course it worked. It was a demo. What were you expecting? This is always going to work. Instead, what I really wanted to talk to you about was this. This is the ASCII artwork in Spring Boot. This ASCII artwork took a long time to get right. We have people on the Spring team that are doctors, PhDs, people in their previous lives worked in nuclear physics, star stuff, the very celestial bodies, and the heavens above us were their daily bread and butter. So it makes me very happy to imagine that someday, somewhere, somehow, there's a GitHub issue that said, damn it, we need good ASCII artwork. I think you'll agree they did a great job. Now, it's at this point that I'd like to take a brief moment to just talk about what I consider to be a very serious, very glaring deficiency in the IntelliJ JetBrains product. For while I am a fan, I think this was particularly short-sighted and a big problem, and I think we should do something about it. What the hell? Why is that there? That checkbox, once selected, disables the banner artwork. That's a dumb feature, and I think we should do something to fix it. So I did what all of us do when confronted with adversity and challenge and fear. I went on the internet and I cried loudly. And I was given a message of hope from my friend Jan Sebron, who's a software developer by passion at IntelliJ IDEA JetBrains. And he responded thusly. We're gonna make him, don't worry, my friends, we're going to make IntelliJ great again. So anyway, I've got an application. It's got a REST endpoint. Let's confirm as much. Localhost 8080/reservations. Voila. There's our data. It's a hypermedia, right? So these endpoints give me the records that we expect as well, but they also give us links, and these links help to decouple the client from the producer of the API, right? So the client is expecting to find endpoints and to find data at those endpoints, but in order for it to further navigate the endpoints, it just needs to follow these links. These links tell it where it can go. The client is no longer coupled to the URL structure itself. They can follow the hypermedia links. These are an implementation of a design pattern called HDOS, or Hypermedia as the engine of application state. It's the idea that every REST resource, no matter, it's the idea that every REST resource should have information enough in the response for the client so that it doesn't need to know upfront or a priori about the REST structure, right? About the API structure. This helps decouple clients from services, like I say. It also provides a navigable sort of path. It lights the path ahead for the service. It helps you convey state. You might have a link that shows you an option to check out when it's a viable time to check out a shopping cart, for example, but you wouldn't otherwise. That client doesn't try and call an endpoint in the wrong flow, in the wrong order, because there's no link prompting it to do so. So these hypermedia endpoints give us a lot of value, and they're very useful, in particular when we build distributed systems, because when you move to this distributed systems world, everything is an API, and very few developers, and I mean very few developers, write documentation, and absolutely none, zero, categorically zero, read it. So you need to make it as humane as possible for developers to consume APIs. This helps you get that. So I have a hypermedia API. I can deep link into it. I can go to 1, 2, 3, et cetera, right? I have all these records. I can also go to the search endpoint here, and it shows me that there's a finder endpoint called find by reservation name, and I can send a request into that, and I'll look for my buddy James there, and there we go, right? So make a request, found all the results. I'm getting all that for free by using Spring Data REST, right? I also have in the application, I have the metrics, I have the actuator, the Spring Boot actuator. The actuator is a framework that requires that we unlock the default security. So management security enabled equals false. Command F9. I'm not even going to rebuild or anything. I'll just use DevTools, right? So come on. There we go. So there's the application. There's the updated endpoints. These endpoints surface information about the application themselves. Again, what I want from a cloud-native system is the ability to observe the system. I want to be able to see what's happening in the system. And who better to articulate the state of that system than the service itself, than the services themselves. I could add a Java agent to the same process, to the same node, alongside the Java process, or underneath the Java as a Java agent. But I would have only a very limited, opaque perspective of the application itself. Instead, the actuator endpoints provide that information in the service themselves in a standardized way. This was inspired by the Google Borg-Mon monitoring approach. They stipulate that all services and all workloads, no matter what their nature, whether they're HTTP or batch or machine learning or artificial intelligence or web or whatever, all surface standardized HTTP endpoints in a way that centralized monitoring infrastructure can then corral and use to form that ever-important dashboard experience. So this gives us a lot of power, but are we done yet, right? I mean, are we done? Is this enough? Surely not, you know? There's things that we're going to run into in this application that are going to become a problem only when we start to scale out and add more instances. The first of which, of course, is security. I just showed you that you can change certain things about the application by sending properties and application.properties. I can even override some of the defaults by going to the command line here. Oops. C downloads reservation service. Maven -d skip test because YOLO. Clean install. What did I do there? Uh-oh. Those guys did something to my build. Oh, we are not allowing that. SR3? They just updated this and my whole build is going to be screwy. Great. Let's see. Okay, very good. So there's that. I can even run the application. I can override the configuration. Thusly, I can say target reservation service.jar -d server.port, for example, equals 8010. And in so doing, I'm overriding the property that I would have otherwise specified here. The heck? Maven. Re-import. Thank you. I could have specified the property here. I could have said server.port equals 8010 here, but I would have had to recompile the jar. That's a non-starter. I don't want to have to recompile the jar as I move the application from one environment to another. Oh, this is going to be a problem. Is it SR5? Start.spring.io. Is that a thing? Yeah, it's a thing. Let's try that now. Seems happy. Okay, looks like for my entire talk, I'm going to have to remember to update these property files. up to this property to Camden SR5. All right, so that's up and running. That's certainly a start, but it's not good enough, right? If I want to configure the application and override the configuration, I want to solve a few different problems that this isn't going to solve. Oh, come on. Maven clean install. Right. Okay. There we are. So I want to solve a few different things that this isn't going to solve. First of all, how do I centralize the configuration so that I can reference the same configuration from one node to another, right? How do I version control the configuration so that if something changes, I can audit the change and then roll it back if necessary? What if I want to live reload the configuration without restarting the process? And what about security? What if I have passwords or locators or credentials, things like that laying around in the file system? I don't want that laying around unencrypted, right? For all these use cases and more, while what I've just shown you is a good start, it's not nearly enough. We need to do a bit better. And so what I want to do is I want to stand up a config service to manage access to that configuration. That config service will solve the centrality issue because all services will talk to the config server to draw their configuration. It'll also solve the auditing requirement because that directory that it's going to use to store the actual repository of configuration will be based on Git or Subversion. It can help solve the security issue because now I've got a central place to interpose security requirements. All configuration must go through the config server, which in turn can be secured. And communication from the config server to the repository of the configuration, the Git repository or the Subversion repository, can in turn also be secured. So MSR5, okay. And we'll say config service application. And all I'm going to do to make this work is I'm going to say @enable config server, and I'm going to configure I want to tell it to run on port 8888, and I want to tell it where to find the directory full of configuration. So I'll tell it to find the directory home, desktop, config. And now that configuration is just a directory full of configuration that I'm going to store here on the desktop. I'm going to clone it to my desktop here, /config. And that done, I can restart this, and it's going to point to that configuration, and it's going to stand up a REST API that other applications can then talk to draw their configuration. Suppose I am a microservice that identifies itself as the Reservation-Service. That's the service that we just built. We'll name it in a second. But imagine I'm connecting to the config server, and I want to draw my configuration. I can see here that there are two property sources, one from Reservation Service.properties, which has all the properties specific to this service, and another from application.properties that has generic fall-through sort of global properties that are available to everybody, right? If there is a conflict between the more specifically named property file and the generic fall-through backup file, the more specifically named file will override the default one. So server.port here would have more precedence, and it would override the default value specified here. That's by design, right? Now, if I do everything correctly, if I revisit our reservation service and I point it to the config server, it should start up on port 8000 according to this, and it should have access to this message, hello world. So let's go ahead and see that in action here. We've got on the class path, we should have the config client, right? There's that. So now we can just create an endpoint, REST controller, class, message, REST controller, private final string value. And what I want to do is I want to inject that message that we just looked at, the message key from the config server. And I can do so in the same way I would any environment variable, or sorry, any property inside the Spring environment abstraction. I'm going to create an endpoint here called message, and I'll just return the value. Now, the value as designed, as specified, is good enough, but I can imagine at one point I'm going to want to reload that configuration. So I'll annotate this bean with @refresh scope. If everything goes to plan, no, I'm not interested in that, thanks. If everything goes to plan, then that should spin up on port 8000. We should be able to see the message under /message. So localhost 8000. Well, reservations first, I guess. That's our first endpoint. Okay. What is going on? Oh. I need to tell the config client where to find the config server. So there's a few things it needs. It needs to know the name, Spring application name. That's the Reservation-Service. And it optionally needs to know where the config server itself is located. And you can do that with localhost, you can say Spring Cloud Config URI equals this. Now, it's worth noting that that is the default value. So this will work even if I omit that. If the server is not located on that host and port, of course, it won't work. But for our purposes, and for the balance of this talk, I may omit that particular property, and that's OK. I only show this to you because I'm a giver, and I care. You should add it yourself silently when you see it, or not see it later on. OK, here we go. Come on, computer. We don't have time. Good. There's our endpoint. There's the message endpoint. You can see it says hello world. Things are there. Let's go to the config directory here, desktop config. We'll open up the file here, reservation service.properties, and I'm going to change this message to say hello devops US, extra exclamation marks. This is to reinforce my credentials and authority on Reddit. Okay, so there's that. I'm going to say git commit -a -m YOLO, and my property file, now having been changed, is immediately visible in the config server itself. But my config client has no idea what's just happened. I need to tell it to redraw its configuration, to refresh its configuration. I can do so one of two ways. I can use the Spring Cloud event bus and use something like Apache Kafka or RabbitMQ to federate changes across also connected members of the cluster. Or I can just trigger another actuator endpoint, in this case, one called refresh, which I'll do so here, localhost 8000/refresh. That'll send an empty HTTP post to the web server. But before I hit go, let's set the stage. I'm going to hit enter, and then I'm going to hit Command-Tab, which on a Mac means go to another application. Then I'm going to hit Command-R, which means refresh the browser. And then I'm going to see, hopefully, the result in the browser. But this is, going to go fast. And my fingers are arthritic and poor. So here we go. Ready? 1, 2, 3. Yeah, there we are. Huh? Not bad. We changed the configuration without having to restart the application or even recompile anything, right? The bean was recreated in situ. I can see the configuration immediately. This config server gives us a lot of benefits. As I say, it's central, so now we have the centrality problem. All of our microservices can draw from the same well of configuration. I don't have to tediously copy and paste things from one property file to another. I have the ability to interpose security, both from the configuration client to the config server, as well as from the config server to the source, Git or Subversion repository of configuration. I have the ability to do live reloading, thanks to the refresh scope in the Spring Cloud config client. And I have the ability to support auditing and journaling, thanks to Subversion and so on. Now, this is one thing that becomes very useful in a distributed system is centralized configuration. Another thing that becomes valuable is service registration and discovery. For you see, in a dynamic cloud environment, things are going to come and go based on demand and capacity. As things come to the scene and disappear, I want my services to be decoupled from the location and the awareness of where those things are. I don't want them to call a service that doesn't exist, for example, just because we've scaled down and thrown off a few nodes. So what I'm going to do is I'm going to introduce a little bit of indirection between my client and my service and the IP of my service. And at first blush, this might seem like a use case for DNS. But DNS is actually a really poor fit for what we're trying to do. What I want to do is I want to call another service, and I want to be able to make the decision about how to route to that service on the client. And the reason is because because routing is itself a business logic decision as often as not. Sure, your average load balancer can do things like do things like round-robin load balancing. But what about more sophisticated uses? What if you have a notion of session affinity or sticky sessions, but you're not using one of the well-known, well-recognized types of sessions, like an HTTP session? What if you're using an OAuth token, and you want to pin a request from an OAuth token or to a JOT JWT token to a particular node? Where do you interpose that logic, that business logic, in the router? There's no checkbox in your average common F5 load balancer that says act like Netflix, right? So you need to add that logic somewhere. That's up to you. Routing is a client-side concern, especially for intra-service communication. The other thing is that DNS has a lot of limitations that it's not like they can't be fixed. It's just that they're not really present. They're not really front of mind when we're dealing with them. So for example, DNS, in order for it to scale, requires that the clients cache the resolved entries. Fair enough. That's a natural and very useful assumption for the wide web. But for intra-service communication, in which case things are going to come and go based on a lot of sort of parameters that we can't necessarily control, having cached records is a bad idea. It means I can potentially call a stale node, something I want to avoid. I can get around this, of course, by having a time-to-live value of 0, but that affects the life cycle of all those that are using that same DNS server. Another problem is DNS. You can also solve the caching issue for specific clients, right? But you need to know where to do that. The JDK caches DNS. So if you're using a DNS load balancer, you end up essentially defeating the load balancer, right? If you call a DNS load balancer and you get the IP back, the first IP address is the one that Java client is going to keep on using. You end up defeating the load balancing you're trying to get in the first place, Again, there are ways to get around this by changing things in the JDK and the bowels of the JDK, but it's just not really a good idea unless you know all the places where that's going to happen. And if you do make a call to a node that doesn't exist, you may end up with a timeout, right? You may end up with a situation where you're blocking, waiting for a response that will never come. Hopefully, you've all done the right thing. You've all read and internalized and applied Michael Nygaard's amazing book, Release It, and you've specified aggressive client-side timeouts for everything. You've all done that, right? For all the code in the JDK that uses anything in the java.net packages everywhere? You sure? No? Pop quiz, what's the default timeout for example, java.net.url connection? It's 0, right? That means it'll wait indeterminately for a reply. But that may never come. So it's better to be in a situation where you can ask the question, is that service there? DNS answers the question, where does that service live? It can't tell you if anybody's home, right? So what we need is a way to ask that question. Tell me if that service is out there and if I should bother calling it. I'd much rather find out before I make the call than after and I end up blocking. So for this, we're going to use a service registry. And Spring Cloud has an abstraction, the Spring Cloud Discovery Client abstraction, that makes it dead simple for you to interop with lots of different service registries out there. There's a lot of great choices. There's Apache Zookeeper. There's HashiCorp Console. There's Cloud Foundry itself supports service registration discovery. There's etcd. There's also Netflix Eureka. And I happen to be a big fan of Netflix Eureka for a couple of reasons. First of all, it's super simple to set up, and I'm nothing if not very lazy. And second of all, it happens to have been used at scale by one of the largest companies on the planet, so we know it works, right? So we're going to say Eureka Service. So Eureka Server, I'm going to use the config client. We'll hit generate. And I'm going to open this up. Oh, that's the Reservation Service. Complaining about not being able to find a piece of infrastructure. So in order for this to work, I need to change the build again. Camden SR5. Maven re-import. OK. And we need to specify the same things as we did before. This is a Eureka service, so we'll say that. And that should do. Now, if everything goes to plan, that'll spin up on port 8761. And we can use that to now discover our service, our service that we need to retrofit to talk to the registry, to register itself with the registry. We need only one thing to make that happen. We need to opt in to the service registry, to the discovery client abstraction in Spring Cloud. So we say @enable discovery client and restart, and it'll automatically talk to the registry on port 8761. So let's see if that works. Here we go. A few things to notice. First of all, no applications yet, nothing there. And second of all, very well done mouse overs. That took a year. We have people for that. Anyway, there's our application. There's our service. It's there waiting for us. There's one instance of the service. It's on this IP, this service ID, and this port. It's available for now. It's been advertised, and it's available for consumption from a client. And that's what we're going to do. We're going to build a special kind of client called an EdgeService. In order to do that, I'm going to use Spring's web support, the config client, Eureka support, Zipkin support, Feign for distributed or for declarative REST clients, Actuator for operational concerns, REST repository support, and Lumbach, okay, and DevTools. So I'll hit generate, and open this up. And again, I have to change the build. Okay. Camden, SR5, Maven re-import. I would be changing it even if I wasn't concerned about the stability of that particular piece. I'd be changing it just because I don't want to download all the Maven dependencies right now. So @enable discovery client, Spring application name equals reservation-client. Okay, and this is an edge service. An edge service is an ideal place to handle any kinds of client-specific concerns. And by clients, I mean things like your iPhone, your Android, or your PlayStation, or whatever, right? So I want to handle things like security, payload, and protocol translation and transformation at the edge service, rather than having to change every single microservice in my system. So as requests come in from the outside world, they go to the edge service, and there they get transformed and secured and enriched and processed, and then sent down to the actual microservice in question that can handle them. One thing that it's common to do is to just proxy requests. An HTML5 client, for example, may want to talk to downstream services, but it doesn't have unfettered access to those services. And I can give them that unfettered access by adding access control headers to every single microservice, but that would be a bad idea. It would put me in a situation where I am having to change every single microservice just to accommodate the introduction of a new HTML5 client. Instead, let's just proxy the request through this edge service. And I can do that pretty simply by using the Zool microproxy, right? So there's that. If I run this, this will give me a bunch of endpoints named for the registered services in the service registry, mapped to the localhost 9999 / service ID. So localhost reservation-service / reservations. There we are. There's the edge service. This is the actual service here. Actual service, edge service. Actual, edge, actual, edge, actual edge, actual, edge, actual, edge, actual, edge, actual, edge, actual. Anything you notice that's different? First of all, the URL is a little different, right? The service ID is in the context of the application request. That helps the Zool proxy figure out where to route the service request to. How does it know which instance to use? Well, it uses something called client-side load balancing. That is to say, it picks from the client code in the proxy itself. It picks all the different service instances that are in the registry, and it says, I want to find one, and it uses whatever algorithm we give it. By default, the algorithm it uses is round-robin load balancing. But you can plug in other strategies, including a strategy that is aware, for example, of an OAuth token or something like that, right? Or data locality or data center aware load balancing or data sharding or whatever you need, right? You can do that here. The other thing you may notice is that the URLs are different, right? The URL from the actual service here versus the proxied request. That's because the proxy is sending a request that has an origin URL in the header. So that is showing up in the client. OK, so that's certainly one thing. That's certainly one way to solve the problem. Sometimes clients want a specialized view of the downstream data. They don't want the data just unprocessed. They want to get a synthesized view. Maybe want to merge data from different endpoints, or they want to transform the results, or do something like that. So in this case, you can create an API adapter, right? So I'm going to say API, or say reservations, API adapter, REST controller, 2 L's, and I'm going to call this a REST controller, and I'm going to map this controller to / reservations. And I'll create an endpoint here, get mapping / names. And all I'm going to do in this endpoint is I'm going to return a collection of names, just the names, not the whole surrounding JSON envelope, right? The whole, this is called a resource object. This is implemented by, or provided by Spring HotOS, which we talked about earlier, right? Spring HotOS has this idea of a resource envelope object that has a payload of type T, in this case, a payload of type reservations, which in turn has content and links, right? So I want to take that JSON and turn it back into a collection of Hypermedia resources. I could use the REST template, right? We probably know about the REST template, right? The REST template is an HTTP client for calling other services. I could do that, but it doesn't know about our load balancer. It doesn't know about Ribbon, and I can teach it about that by saying @load-balanced, and that would certainly give me what I want, but this is a little low level. What I want is to call that downstream service and to not waste too much time ferrying bits and bytes and HTTP headers and status codes around. I want to get the benefits of HTTP, but I don't want to have to spend too much time writing that code. So what I'm going to do is I'm going to use Feign. Feign is a library from Netflix that makes it dead simple to create declarative REST clients, right? I have Feign on the class path here. Feign in English means to pretend or to act as. So if you see an animal, a dead animal in the forest, or a forest that looks like it's dead, its tongue is hanging out like that, it's not actually dead. It's pretending to be dead. It's feigning death so that you'll leave it alone, right? It wants you to move on. It's dead, but it's pretending to be it. It's feigning death. In the same way that WebSphere feigns utility. It's not actually useful. It's just pretending to be, right? So we want to create a feign client that can talk to our downstream services, but I don't want to spend all that time writing the REST code. So I'll create a feign interface here. Feign client, reservation-service. Okay, and I'm going to say resources of reservation, and I'm going to read the data. Now, the reservation type here doesn't exist on the class path. I need to create that class here, like so, reservation, string reservation name, and I'll make this a Lombok type. There we are. Okay, now, going to say that I want to make an HTTP GET call to the reservations endpoint whenever somebody makes a call on this method, whenever somebody invokes that method. I can inject that here. I can say private final reservation reader R, inject that into the constructor, and then down here I can say return R dot read dot get content dot stream dot map, and I'm going to take the results and unpack them into a collection of lists, or to a collection of names, right? So there we are. There's the reworked code, and that would certainly get us part of the way there. That would be what I want, right? That's much cleaner than using the low-level REST template. Okay, is that enough? Am I handling all the use cases? Probably not, provably not, right? I've ignored robustness here. I want to make sure that if this fails, if I try and make a call to a downstream service that has no instances, that I want to be able to degrade gracefully and load bounce to another node, so or to fail over to something as a fallback. So I'm going to use a circuit breaker here. I'm going to specify a fallback method so that if something should go wrong, it'll call the fallback method, right? Return new array list. Okay, there we are. There's my simpler fallback method. In order to make this work, I need to activate support for circuit breakers. Okay. Now the final thing that I'm going to care about, do I have this on the class path already? Yes, I do. So let's go ahead and see this in action. I've got now an application that will load balance requests across the different registered instances in the registry. If there are 0 instances, it'll fall back to the circuit breaker, which will then call the empty array list and return something. This is very common in high-performance websites. They'll say, oh, well, you called this endpoint, but the service is down right now. Here are some machine-learned. Maybe instead of getting a search result, you get a set of machine-learned recommendations from across the web. Right? That's a useful performance tactic in a high scalability system. So I've got my names here. If I kill my downstream service here, it'll circuit break. I get an empty array list. Right? And if I do that enough, it'll stop trying to even call the service. See, it's slow right now, but now it's fast. It goes directly to the downstream service. That's because it goes directly to the fallback. It doesn't bother calling the downstream service because it knows that service doesn't exist. So that circuit breaker, by the way, is a great place to introduce monitoring and observability. So we talked about it earlier, right? I want to be able to see the flow of data in my system in between nodes. I can't change other people's code. I can't make them write better code. I can't make them use Spring. I can't make them use Cloud Foundry to build more robust services. But if I monitor the flow of data from my services to their services, I can at least understand whether their services are working or not. I can't add my monitoring infrastructure and agents to their code bases. So that circuit breaker has to stand in, if you will, as a proxy for monitoring their code, right? I can at least understand what's happening that way. So here we are. What I'm going to do is I'm going to build a dashboard to monitor the circuit breaker in my application. So Hystrix dashboard, @enable discovery client, @enable Hystrix dashboard. Open up this property file, Spring application name, Hystrix dashboard, okay? And there we are. Meanwhile, this has healed itself, or it will have healed itself if I, where's my application? There's up. This eventually, well, there you go. So the service eventually reconnects, it registers with the registry sends out a heartbeat event, the other connected nodes get that heartbeat event, and they invalidate their cache and reconnect to the registry to draw their the services. So this worked, it healed itself. If you have a cloud platform like Cloud Foundry, then it'll automatically restart the service for you. So you don't have to do that. You can sleep easily, knowing that the platform is wearing the pager for you. Now, that dashboard is here on port 8010 hystrix.html, and it's expecting a heartbeat event stream. So a stream that'll tell us the status of that circuit breaker. And we can get that from here, localhost 9999/hystrix/stream. One thing that I should underscore is that this endpoint is endless. It has no end. It is infinite and without end. It goes on and on and on and on and on forever and ever and ever and ever. And whatever you do, my friends, whatever you do, and I cannot underscore this enough, do not curl this endpoint. So grab that endpoint there, paste this into the URL, hit monitor. And as I make requests on the left, you can see the moving average is trending ever upwards on the right. We can see that data is moving through the circuit breaker just fine. The green circle is green. If I were to kill the reservation service again, this would turn an ominous color of red, and this would say open, right? The circuit would be open. Traffic would not be allowed to proceed. Now, this is one way to get visibility in a distributed system. Another is to use distributed tracing, and that's a very good idea if you can control the nodes in the system. So what I'm going to do is I'm going to build a Zipkin server
that talks to the config client that uses discovery support. Zipkin stream, okay. And my Zipkin server is based on the Twitter open source project called Zipkin. Zipkin is a way of tracing, or visualizing rather, trace information. If you can intercept every message that enters or exits your system, be it via the Zuul microproxy or the REST template or Apache Kafka, RabbitMQ, or the Spring MVC endpoints or the Spring Data endpoints or anything else, if you can trace every single endpoint that sends a message or receives a message, then you can propagate a UUID, a correlation ID, something that you can use to find out the flow of the application. So that's only useful if you can do that to everything, though, right? And it's a lot of code, even if you can do it. So thankfully, we have an abstraction called Spring Cloud Sleuth, which is a distributed tracing technology, right? It gives you the ability to trace messages that have flown through all the normal sort of pathways in a Spring Cloud application. Let me add the UI. I forgot that. Zipkin server. The Zipkin server is written by the folks at Twitter. It's very easy to run and to use as a Spring Boot application because, well, it is a Spring Boot application, right? So there's that. We're going to say @enable Zipkin server, and we're going to spin this up, and that'll start up on port 9411 if memory serves. Localhost 9411. Come on, computer, time's a wasting. Awkward. Oh, no binder. Get rid of the stream one. Oh. So what we've looked at so far is we've looked at a way to build an application that is robust to service outages in case of the read use case. When we call a downstream service that doesn't exist, it does the right thing. We've looked at how to build an application that is able to benefit from the elasticity of a cloud environment. It's robust in the case of service outages and topology changes. It's agile. It's easy to change and evolve over time. And we've also looked at observability, both in terms of the actuator and in terms of the emergent behavior in the system itself, as we looked at the flow of data from one node to another from, for example, the circuit breaker dashboard and the Zipkin distributed tracing platform, which we can see in action here. If I go to Reservation Service, this should have it. Let's restart that. This does have it, right? Zipkin, yeah, there it is. So Zipkin is in play on the service. As long as both of them have it, then they're going to both, whenever the request is processed, it'll publish out of band. It'll publish span information to that Zipkin server. Let's see if that's working. Localhost reservation names, please work. OK, 8,000 reservations. There's this, 9999 reservation names. There's that. So it's both sides are talking. There we are. So now if I go to the Zipkin server, I can see that I've got a service and a client. Click on the service, hit find trace, and I can see that these requests have been made through the system. I can click on, let me see, more recent ones. There we go. This request took a total of 27 milliseconds. It started at the reservation client, and it went to the reservation service. Here's the relative timings of the requests in the system. The waterfall graph, I can click on each element in the waterfall graph, and I can see tags or information that identifies the particular pathway that message took as it went through that node. Now, this is not about warehousing. It's not about finding out what Josh did on the website 5 years ago. It's more about online telemetry. What's happening right now? How much money did we make in the company last year? I don't know, but I can tell you what the average latency on the website has been for the last hour. So today, we've only gotten to just the briefest of chances to look at a few things in the Spring Cloud ecosystem designed to support agility, robustness, ease of evolution, and scale, as well as observability. If we had more time, we'd look at how to do consumer-driven contract testing with Spring Cloud Contract to make it easier for clients to talk to other services without actually having to run those services for integration tests. If we had more time, we'd talk about how to make the right use case more robust by using messaging, eventual consistency, and things like the Saga pattern. And if we had more time, we'd talk about how to compose messaging-based microservices built atop things like RabbitMQ and Apache Kafka, and build stream processing pipelines using Spring Cloud Dataflow. If we had more time, we'd talk about single sign-on and how to secure different microservices using OAuth tokens so that you can reject out-of-band requests that are unauthenticated, right? If we had more time, we'd talk about all that and much more, I'm sure, besides. But since we don't, I want to thank you all very much for your time. It's been a pleasure. If you have questions, as I say, don't hesitate to reach me on the inner tubes. Also, I'll be giving a talk that's introducing reactive the reactive support inside of Spring 5 due this summer, later this afternoon. So I hope you'll join me there. Thank you very much. Cheers. Yeah, it's online, and there's also that workshop is a 3-day lab. So if you get that GitHub repository, there's 3 days of exercises and examples and instructions, and we cover a lot more than what's just covered in here. Thanks very much. If you liked it, please vote, because I don't know if they'll invite me back.